Okay, I've never tried this before, but I'm going to try it now. I have 1, 2, 3, 4 parts. So what I'm going to do is try to make all 4 of them at the same time. I've already done this op on all 4 of these pieces. Now I have to cut a curve in here, face this off. Real simple, but you know, could be fun if I screw up. So what I've done is I've come in and I've used my indicator here to indicate from here where my tools are touched off. So all of my tools are zeroed right here. I've used this indicator to come in and find the height here and here and here and here. And I've also come in to get my X here, 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 and here. And my Y, I'm using the back of the vice jaw just because they're obviously the same thing as the axis there. So the way I'm doing this is I'm zeroing off of the back bottom corner of each part. So in order to find the top of my parallel, I used a 1, 2, 3 block, clamped it in on top of the parallel, hit it with a hammer to basically be the same thing that I'm doing with the part. I zeroed on top of that, and then I took the 2 inches away, which gives me the top of the parallel. So then I put each part in, and because vice 1 and vice 2, the parallels are the same. You see G54 and G55 are the same Z height. G56 and G57 are the same Z height. So the X is different in every one. So G54X is here, G55, G56, G57. So, and then if you notice, the Y is the same in both as well because I use the back of the vice jaw. So the Y for G54 and G55 is here, and G54 or G56 and G57 is there. So again, never done this before, but we're gonna see how it works. So I've got them in the vice jaws, I have them indicated in, and I've gone into my setup. If it'll come up, and right here I've put in work offset 1 is where it starts out, which is basically G54, and it will duplicate 4 times and an increment of 1. And then I've got it ordering by tool. So let me close that, and if I go into the file, which is here, so if you look, there's op2 times 4, and you follow down here and you've got a G54 here. Now if I scroll down through this operation to my next op, see, here's the same operation, phase 3, and it's got a G55. So now I'm going to scroll down again till I see phase 3, and here's phase 3 with a G56. So basically it has duplicated that operation 4 times, and it is simply changing the offset. So here's phase 3 again, G57. So now I should have a second operation after this, starting all over again. So G54. So here we go. Phase 4, and here's my G54 to say, hey, use the G54 offset to run this program. So now and apparently these are easy. So G55, G56, and then G57 somewhere. Okay, I'm not seeing it in here, but I'm sure it's in here. Huh. What the heck is it? Oh, there it is, right there at the top. I didn't see it. And then you'll have the next one, and we're back to G54 again. So on and so forth. So this is the G code that runs the program. So I have put it in my program here. So 733 or 7033, and if we go to memory, this is the same file that you see, well, that I had open a minute ago. So if everything is right, I should be good. So I'm going to change my feed rate 100% on everything and go to 25% rapid. I'm going to put in op stop here, so it will stop after every op, and close the doors. Oh, and I don't know if that was clear, so if anyone wants to know, this is where I set all of my tools. How do I do that? I use a tool setter. So this little thing that's stuck to that. So this tool setter to the top of these pins is exactly 2 inches. So if I take this and I put it on the back of my vise, I can run my tool down to here and basically jog the tool down until I get a 0 here. Once I've done that, if I go to my offset page, and so here's the tool that we're currently at. So this would be tool 10. Here's the offset. And what I would do is I would do tool offset measure. And so what that's going to do is that's going to update this with the location that it's at right now. Obviously it would be down here. And then once I do that, it would be like negative 8.2869. And then I would go down here, negative 0.2, enter, and that would update it to the 10.269. And you would do that for every single tool. And what that does is that tells the machine that this tool, which is tool 10, 0 is exactly right here. And I've gone through that with every single tool in the carousel. So if you see all of these are all of my offsets, and it's pretty simple. So it's this stuff is not as hard as I thought it would be when I first started this. I thought this was going to be rocket science, but honestly I think anybody could really do this. And so some people will set their tools on the surface that they need. The problem with that is a lot of people, I want to do this one tool, and so they will take that block, set it on here, go down, get their offset, and man, I am exactly right there. But what if I have multiple offsets? What if I have 2 parts I want to do, or 2 vices that are at different heights? These vices are not exactly the same height from the table, so this Z offset is different from this Z offset. So if I want to do 4, say I have 2 vices or 4 vices or 2 double vices where I could have 4 more parts in here, if I set on here, I'm going to have to then, for this vice, measure the difference between here and here for my G56. So 54, 55, 56, 57. But the way I was taught to do it, which I think makes more sense, is you 0 everything here, and the G54 offset would be the distance between here and here. So the difference in height from here and here. So now, if I go back to my offset page, here's my G54. We know how to set the X and Y by indicating here and here, and that gives us our X and Y coordinates for our G54. But what about our Z? So if you were to set the tool here, you would have a 0 Z offset here. but because I set it here, I can then measure the different distance between here and here, from here to here, from here to here, from here to here, which actually my 0 is down here. I forgot about that. But I did measure it correctly. So my Z is actually a distance between this surface and this surface and this surface and this surface. So if you notice, the Z is the same height for these two and the same height for these two. So there's a different number for the bottom two than the top two. So that gives me, obviously I have the same set of parallels here and here. So these two will be at the exact same Z height, and these two will be at the exact same Z height. So there's my parts. I'm going to shut the door and we're going to see if I screwed anything up or if this is actually going to work. So I'll make sure my coolant is on here and way back there, and shut the doors, go to memory. So here's my program. Make sure I'm on 70033. Here is the list of tools that I'll be using, and then it does the op. So I've got it on op stop, which will stop at every different operation. So it will do part 1, part 2, part 3, part 4, come up and wait for me to hit the green button to make sure I did this correctly. So this is what I'm doing. It's just a simple, easy part. I need to hit shift while I do this. There we go. So it's just an alignment jig that I'm using for putting something together at work. I need this exact distance between the bottom of something and something that I'm gluing to the back side. So it's a really simple part. I have gone into my tooling and I've said, hey, I want to face this off. I'm doing that at a 45-degree angle with a 3/8 end mill. And then I'm going to, the blue line that you can barely see here is a facing pass with a face cutter. And I'm going to go in with this tool here and rough out this pocket. Man, I forgot why I added that, but there's a reason. And then I'm going to contour this face here. So it's going to start with tool 10. It's going to go to tool 3, go to tool 9, go back to tool 10, and finish each one of these parts. So hopefully nothing's going to blow up. So I'm going to go to 5% rapid, which you see here, and I'm going to hit start. So now I'm going to go to 100% so it can change its scope. Okay. And it looks like I've got my setting. Ooh. Why is it doing that? Oh. Yeah, I've got it cutting pretty wide there. So this is the 45-degree thing that it's doing. And my parts are cut. There we go. See if that works. My parts are cut lower than the model shows. So my what do you call that? My stock in my drawing is actually a good bit taller than what my stock is here. I actually cut it a little shorter than I expected to. So I am going to bump up my feed rate and see if we can jump through this pretty quick. And now it's going to change heights. Go back down. So you can see it just kind of coming through there like that. What I'm going to do now is come over here and check. So it's going to go down 4 times. Holy crap, that's a lot of stuff. So that's a lot of unnecessary machine time. But I'm going to let it go. So just pretend they're stock there and it's milling the top off. So What I've done is I've increased my feed rate to 200% just to kind of bust through this a little bit faster. It is going to have hardly any stock to remove, so I'm going to jump the speed up quite a bit. It's barely going to get in there and remove anything. And for this operation, which it will do here, 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 and here, I can let the feed rate, you know, be quite a bit faster. So when it stops the next operation, I need to remember to go back to my normal feed rate. But anyway, I don't know if anybody wants to watch this whole thing, but I don't do video editing, so feel free to fast forward at this point. Okay. It's starting to engage the top of the part. Cut some of that off, and I've got a little bit of stock to leave on the top, so it's not going to go all the way down. We're going to save some of that for the other cutter that I've got. So, let's see, cutting that off, and I'm going to hit 100% feed rate. And I may have trimmed that one a little bit more than it should have gone. Adjusting the feed rate up again. Hopefully I won't take a bath in all this coolant. So far, it looks right. And I've, just so you know, normally you can't open your doors like this on the newer machines. If you open the door, it stops the machine. So this is a safety feature, but it sure does make it a lot easier to video where you can see versus that where you can barely see what's going on. So I'm far enough back that it's pretty safe. And these older machines, you can actually override that. The one that we have at work, you can't override. So anyway. I'm going to pause the video while it busts through these operations, and hopefully nothing crashes and I will be back so you don't have to watch this whole process. Okay, I'm back. I'm on the last one of these. There we go. So I kind of screwed up apparently. If you look in here, this one isn't getting faced off all the way, and I actually need this edge to register against. This one's nice and flat, and so is this one. So, yeah, that wasn't very safe. But the good thing is I only needed 3 of these, and I had enough stock left over to do 4, so I figured it wouldn't hurt to go ahead and make an extra. And it looks like my extra is the screw up. So what I may do is run this on this block one more time with a set of parallels that's a little bit higher, because I've got enough meat in this for that not to be a problem. In other words, this surface down here does not matter at all. This could be a shorter distance and it would be perfectly fine. So I'm going to rerun this piece just a little bit higher than what it is now, if one of the other 3 screws up, but I'm hoping that we're good. I guess we'll find out. So I think this is its 3rd pass on the 4th block, and it's still not touching any material, so I should have cut that off a little bit more a little bit more material to spare, but I didn't. My bad. So here's the 4th pass, and hopefully we're going to start hitting some material here. And there we go, we're hitting some. I'm going to slow my feed rate back down. So you can see it's going a little bit slower. I had it on 200% just a minute ago, so it was traveling quite a bit faster. Basically because I didn't want to sit there for an hour and a half watching it do that. I'm going to go ahead and speed this up just a little bit. But it looks like I'm going to get 3 good parts out of this, hopefully. Okay. And there it goes. Alright, so it has stopped on this operation. If you notice this MO1, that is an op stop. So that's an optional stop in your program. So as soon as it hits this line, it's going to stop and wait on the next line of code because I have this option selected using that button. So I can hit start here if I want to, and it'll go to the next operation. Normally you wouldn't do this except for the first time you run a part, but if you notice my feed rate, I've overridden it to 130%. So before I do that, I'm going to go back down to here and turn that off and hit start. Let it change tools. And now it's going to do that. So I'm not going to open the doors because I will take a bath with it like that. And it's going to get the last couple of thousandths off the top of that with that face mill. It just does a little bit cleaner job than the other one I had. Don't sound like it did anything, but we'll see. You can barely hear it machining. I don't know if you can hear it in there. See if I've got something that's not quite as splashed up. So let's just, once it gets done with this, I'm going to hold it using this button, and I'm going to turn my coolant off. Now that's still spinning, but you can see this one, you can see the striations going this way, and this one is much smoother because you've got a much wider tool there. I'm not going to touch it, and it kind of covers a bigger area than this does. In all reality, this would be perfectly fine, but I just wanted you to see the difference of those two tools. So now I'm going to turn my coolant back on, and I'm going to hit the green button and let it go to its next part. What I was a little bit worried about on these operations, because they're so close together, I was worried that the tool was going to come down for, say, part 3 and kind of run into part 4 as it started its tool path, but it doesn't look like that's happening, so should be good to go. Yep, just barely avoids it. Check this out. See the little coolant thing? You can change the direction of your coolant. Is that not awesome? Okay. So there's that, and here comes the next up. So it's going to stop right here. I'm going to take my air gun. If you are listening on headphones, you may want to turn your volume down. Just blow the coolant away so we can see in there a little better. And I'm going to hit go. We're changing tools again. And now it's going to do the roughing part. So it's going to start just a little bit above the stock, but actually this is the adaptive, not the roughing. So it is going down, cutting, coming down a little bit further, cutting, coming down a little bit further, cutting. Okay, I figured it would be engaging the material by now. Let's see. see, we are on this toolpath. Ah, there it goes, I just heard it. So just above the stock there. See it come up. Okay. So this is the actual code that it's running to do all of these things. This is what you would be having to do by hand on that thing over there. So I gotta say, having a CNC mill will spoil you if you're used to a regular mill. Although there are some things that the other mill is quite a bit easier for. And you can do setups, so in this one I'm a little bit limited in my Z height. I had a 3-foot long piece that I had to machine, and I couldn't do it on that mill. I had to do it on this one because I could hang the part off the side here and clamp it here, and I could work on the very end of it by taking the head and rotating it around and doing all the parts here. Uh-oh. And let me stop this. Let's see, I'm going to turn my coolant off. I'm going to do a feed hold. And I'm going to turn the spindle off. So what I want to do is measure the distance from here to here with my handy dandy dial calipers. Ooh, it's supposed to be 0.38. Why is that off? Measure here. So that is what it's supposed to be. Huh. Let me do it this way. I'm going to pause this while I check. Okay, I'm back. So I just realized I was measuring it and I was off. I had less of a step here than I was expecting. So got some collet blocks out to make sure that my calipers were not wrong, and they weren't, which I guess is a good thing. And then I realized that I had left stock for this operation. So there are I think 0.06 of an inch that I'm leaving on the bottom that I'll be doing in this operation here. So I'm just going to be sweeping the bottom and getting rid of those. So I just need to wait and see what it does, I guess. So anyway, that's what we got. So it is doing the second one in the adaptive, so you can see it going. So there you go. I'm going to pause this so we can go to the next option.